everybody, welcome to on Mathmax tutorial. Today we have seen amazing, crazy and interesting integration, and today integration is integration under root cot x dx. If you want simple solution, then watch video till at the end, okay? And if you like the video, then like, share and subscribe my channel. Thank you. Yes, okay, let's do start. First we take I is equal to integration under root cot x dx. Here we can put the substitution method for the suitable example. Here we put t square is equal to cot x, then differentiate this function, we get 2t dt is equal to minus cosec square x dx. Then we know that cosec square x is equal to 1 plus cot square x, okay? Then minus 1 plus cot square x dx, and here 2 dt dt. Yes, okay. Then minus 1 plus cot square x is equal to t square, then cot x is equal to t square, then cot square x is equal to t raised to 4, we get dx, and then 2t dt. Then we want dx is equal to value, then dx is equal to, we get minus 2t dt and divided by this term 1 plus t raised to 4, okay? Then equation 1 becomes, okay, then equation 1 becomes I is equal to integration t into under root cot x is equal to t, and then minus 2t and divided by 1 plus t raised to 4 dt, okay? And this term becomes minus 2 raised to minus 2t square and 1 plus t raised to 4 dt, okay? Then we can 2t square is term adjusting as integration minus integration t square plus 1, then plus t square minus 1 divided by 1 plus t raised to 4 dt. Yes, okay. And we can here separate the values, then minus integration t square plus 1 divided by 1 plus t raised to 4 dt, then minus plus minus minus t square minus 1 divided by 1 plus t raised to 4 dt. And we can say here this is the term minus I1 and this is minus I2. Now we can here separately solve this both I1 and I2, okay? Let therefore I1 is equal to integration t square plus 1 divided by 1 plus t raised to 4 dt, and then this equation throughout dividing by t square, then equation becomes 1 plus 1 upon t square, then this equation becomes t square plus 1 upon t square and dt, and t square numerator t square plus 1 upon t square, this term can be written as like 1 plus 1 upon t square, and this is term t minus 1 by t bracket square plus 2, we can adjust like as it is, okay? Then again here put the substitution method, that's mean here we put u is equal to suppose t minus 1 by t, okay? Then differentiate this equation becomes du 1 minus minus plus t square and we get dt, and then this equation becomes as, we can write here du upon this equation u square, okay, u square, and plus this is the root 2 square, okay? And now here we use the formula tan inverse, okay, 1 by upon root 2 tan inverse, and x that's mean u upon a, that's mean this is the root 2 plus c is the constant, okay? Suppose here say c1 is the constant term, and then back put u is equal to, then back put u is equal to t minus 1 by t. Yes, okay, t minus 1 by t, the 1 upon 2 we get tan inverse, and u that's mean t minus 1 upon t divided by root 2 plus say plus c1, okay? Then equation becomes as, we can say here, yes, okay, and back put t is equal to root cot x, okay? Yes, therefore 1 upon root 2 tan inverse, and this simplification becomes as t square minus 1 divided by root 2t and plus c1, okay? And then back put t is equal to under root cot x, and t is equal to t square is equal to cot x, okay? Then equation becomes 1 upon root 2 tan inverse t square, that's mean cot x minus 1 divided by root 2, okay, divided by root 2. divided by root 2 under root cot x, and this is the plus c1, and this is the I1 value. Okay, now we calculate term I2. Yes, okay, I2 is equal to integration t square minus 1 divided by 1 plus t raised to 4 dt, and this equation divided by numerator and denominator both by t square, then equation becomes 1 minus 1 upon t square and divided by t square plus 1 upon t square, okay, and dt. Then we can term again adjust t square plus 1 by t square as I is equal to integration 1 minus 1 by t square and divide by t minus plus 1 by t bracket square minus 2. Okay, and again here we substitute the method substitution. Suppose put t plus 1 by t is equal to suppose v, and differentiate this function, we get 1 minus 1 upon t square and dt is equal to dv. Yes, okay, then equation this we can write as dv upon v square minus root 2 square. Yes, got it? Okay, and we know that this relation formula of this integral dx upon, suppose this is x square minus x square, we can write as 1 upon 2a, then ln x minus a divided x plus a mod complete plus, suppose this is say c2. Yes, okay, then this equation becomes as we can write here 1 upon 2 into root 2, then ln x, that's mean v minus a, v plus a, and plus, suppose this is say c2. Okay, then this equation becomes, and we can write in terms of t, therefore upon 2 root 2 ln v, that's mean back put v is equal to t plus 1 by t, t minus 1 by t plus t, then minus a, that's mean this is root 2, okay, and divided by t plus 1 by t plus root 2, and suppose c plus c2. Okay, and again back put t is equal to, then we can arrange this equation 2 upon root 2 ln, and we can write t square plus 1 or minus 2 root t and then plus 1, and again this equation becomes t square plus root 2t and then plus 1, and then plus c2 is the constant. Okay, and back put here t is equal to root cot x and t square is equal to cot x. Okay, then this equation becomes 1 upon 2 root 2 ln t square, that's mean this is cot x minus 2 under root cot x plus 1, and divided by t square, that's mean this is cot x plus under root 2 cot x and plus c, this is plus c2 is the constant. Okay, and then equation becomes second, we can write minus I1, that's mean 1 upon root 2 tan inverse t square, that's mean this is cot x minus 1 divided by under root 2 cot x bracket complete plus c1. Okay, and then minus I2 that's mean 1 upon 2 root 2, then ln in mod cot x minus under root 2 times cot x, then plus 1, and divided by cot x plus under root 2 cot 2 times cot x under root plus 1 and plus, suppose this is c2. Okay, and we can replace c1 and c2 as c. Okay, and then final solution becomes this. Okay, got it? If you like this video, then please share, subscribe my channel. Thank you for watching. Bye bye. Yes.